Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Hot Jupiter Orbiting a Star 500 Light Years Away Suggests Stellar Cores are Common. Now, it has been recently reported that a star called Ci Tau, 500 light years away, has 4 gas giant planets orbiting it. The closest planet orbits the star at 0.1 AU and is 11 times the size of Jupiter, not large enough to be classified as a brown dwarf, but close. At this distance from the star, the object is another of those objects which have been named hot Jupiters. And here you see an artist's impression of the Ci Tau system. And there is an article that appears at the website with my name, Dr. Claudia Albers, on this. Now, in Article 142, entitled Hot Jupiter Suggests Stellar Cores Are Not Unique to the Solar System, I wrote about a gas giant planet called COROT2b orbiting a star a distance of 930 years from Earth. The object was reported to be tidally locked, that is, the same side always faces the star. And orbiting the star at such a close distance that it has a period of 3 days, and thus it is at a distance of only 0.04 AU from the star, which means that it would be in the star's corona. The object was also reported to have a hot spot, which does not face the star. This means that the object has very similar characteristics to the stellar cores which have been observed in the sun's corona. And the hot spot not facing the star suggests that it did not develop as a result of the object reflecting light, but that the object is absorbing energy from the star and starting to re-emit energy from that spot on its surface, and is therefore a stellar core or a dead or energy depleted star which is absorbing the energy of a living star. This therefore suggests that all hot Jupiters are stellar cores or dead stars rather than gas giant planets. Now here's an artist's impression of the hot Jupiter, the COROT2b. And as you can see, very close to the star, and this is the hot spot on it. And on the right here we can see an SDO image of a stellar core in the sun's corona, and this is one of the sun's own hot Jupiters. You can see it looks somewhat like a gas giant planet because it even has stripes. You can see the stripes on it. Now, how the stripes conform to the spherical shape of the object. It's a spherical object, so the stripes follow the contours of the surface. So we have exactly the same thing here at the sun. Now, the fact that another hot Jupiter was found orbiting the star at a distance of 500 light years shows that these objects are quite prevalent in the galaxy. And so far it seems that about 1% of all stars have been found to have such objects orbiting very close to their surface. The same star has 3 other large objects orbiting it, with the last orbiting at a distance which is 1,000 times further than the closest, i.e. it orbits at a distance of 100 AU from the star, and thus much further than Pluto orbits the Sun, as Pluto orbits at an average distance of 40 AU from the Sun. The other 3 objects may be stellar cores as well, in which case they are likely to spiral in toward the star. If they are living objects, since they seem to be at least larger than Saturn, they will most likely be small stars, just like Jupiter and Saturn in our solar system appear to be stars, since they have nebular clouds or ring patterns around them. And you may look at Article 336 entitled Stellar Nebula Cloud Structure. Now, the 500 light-year distant star is also reported to have a nebula cloud around it, which is interpreted as being a protoplanetary disk. In other words, a cloud of dust which is coalescing into planets. But if the dust has not coalesced into planets yet, where did the gas giant planets come from? As is admitted in the article written by Clark et al. On the CI-Tau system, current accepted planetary formation theory cannot explain why a gas giant planet would be so close to its central star, as gas giants are not supposed to be able to form so close to a star due to the stellar wind not allowing gases to coalesce into a planet. And so it is believed that these form at large distances from the star and migrate inwards after formation. But since the star is believed to be too young for that to have had time to occur, normal theory cannot explain the presence of this object so close to the star. Now, the fact that the sun goes dark during the STO eclipse season indicates that the sun is not powered by thermonuclear reactions, which are supposed to stop it from gravitationally collapsing, which suggests that gravitational collapse is not the driving mechanism through which star and planetary formation occurs. And here you see two images from the last STO eclipse season, which is supposed to be due to the Earth eclipsing STO's view of the Sun. Now, the Earth from the STO satellite's view has a extremely flat curvature in comparison to the Sun. This is what the Earth's curvature would look like. So it means that it can be represented by this triangle. And if the Earth is here and it's covering this part of the Sun, then this would be the kind of image that we should be getting, just the top part and the rest dark. But this is not what's happening here. What we see here is this part of the corona. You compare the corona here with the corona there, the corona is missing. There's no corona there, and this shows that the corona is actually shrinking back as darkness is progressing across the face of the Sun. And in other words, this cannot be caused by an eclipse, but it is the Sun actually going dark. In fact, the opposite mechanism seems to be in effect as young active galaxies eject material which condenses into quasars, which then unfurl arms and turn into new galaxies, whilst older galaxies eject material which condenses into globules of material, which then fissions into individual stars and thus turn into globular clusters. This seems to be the process through which galaxies populate themselves and unfurl arms full of stars. And you may look at Article 288 entitled Image of Center of the Milky Way Galaxy Reveals How the Universe Works. And this is an image of a galactic nucleus ejecting large amounts of material. Galactic nuclei are very small, only about 100 AU across, but they are extremely bright and extremely energetic. So, and here what we have is an illustration of what happens with active galactic nuclei, how they eject compact globules of material which condense into quasars. And in the course of time, these quasars eventually unfurl arms and become new galaxies. And this was discovered by the astronomer Alton Arp, and he details that in his book Seeing Red. So, since the universe does not seem to use the gravitational collapse mechanism to form structure, and seems to in fact use the opposite mechanism of ejection, separation, expansion, and fissioning, what is the likely planetary formation mechanism? It is the fissioning of stars into multiple stars and the emergence of preformed planets with already intact cores and which formed within the parent star. These cores would have formed in a large, very high electric field pulse in the outer layers of the star, which would result in a matter creation event, which then results in the condensation of the emerging matter into the spherical core, whose condensation process would be aligned with the gravitational wave pattern. The emergence of gravity as a defining force in the formation of the object would accompany the appearance of matter, from within light photons. And you may look at article 185 entitled Stellar Formation, Stars are Formed from Light for more details. Thus, since the gravitational wave has a central minimum, the emerging core or cores forming as a result of the electromagnetic pulse would most likely have central hollows. And you may look at article 348 entitled Venus Bulge, Gravitational Waves and Hollow Planets for more details. In conclusion, the hot Jupiter orbiting a star 500 light-years away seems to be a stellar core, the same type of object which has invaded our Sun in large numbers. The presence of such an object so close to a star also suggests that current planetary formation theory is wrong. The true planetary and star formation mechanism does not appear to be driven by gravitational collapse, but by ejection, expansion, and fissioning. Thus, planetary formation is likely to start with the ejection of material from a parent object, which condenses into a daughter celestial object with a solid core, which is likely to have a hollow center, as the gravitational interaction has an associated waveform with a central minimum. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.